So for this video, I'm going to talk about ventricular fibrillation, or VFib, and hopefully this will piggyback nicely on what we talked about last week with atrial fibrillation, or AFib, and hopefully some of this stuff will start clicking as far as like we were talking about in the week one about what's happening electrically in the heart is what we're seeing on the paper, right? So I'm going to refer back to last week's video a few times. So if you haven't watched that, just real quick, go back, watch the AFib video, come back here, and I think you're going to notice that, like, wow, those two electrically are the same thing in a lot of ways, and where they look on the paper is very, very similar. So let's start it off. Ventricular fibrillation, or VFib. The first super important thing to know about this is if someone is in this rhythm, then they're dead. And this is a person that we're going to be doing CPR on. So going back to what I think was the first day of EMT school when they were teaching CPR, when you turn the AED on and it goes to analyze, it looks for two rhythms. It's looking for ventricular fibrillation, or it's looking for ventricular tachycardia, so VFib or Vtach. And if it sees those two, then it shocks it. We can't shock like a flat line, an asystole, and we can't shock PEA, but we can shock VFib, and we can shock Vtach. And so the idea is, so I'm going to draw the heart here, right? So the idea is, if we've got our heart, and in VFib, so if we remember with AFib, we talked about how, let's get our conduction system here, right? Our electrical pathway. So that should all look familiar at this point. So if we remember, we said like, oh, there's all these like little points, right, in the heart with AFib that are saying beat, and the AV node's doing a good job of not letting all of them through. If the AV node let all of them through in AFib, then you would go in to VFib, because all those signals would go down to the ventricles, and now the ventricles would be quivering too, and the patient would die. So the AV node is like saving our life in AFib. But what happens in VFib is everything up top is working just fine, actually. The SA node's saying go, go, go. But again, just like in AFib, there's a million different reasons why you could be in VFib. So now we've got, instead of all the little red dots in the atria, now we've got all those little red dots all over the ventricle. And so the heart can't beat in any kind of organized pattern, which means the blood's not going to be pushed out to the body, which means you don't get any oxygen, and so you die, right? Pretty simple. That's why if someone's in VFib, even though their heart has electrical activity, we're not going to feel a pulse because there's no organized like beating. So a typical patient we're going to do, what we're going to see with this is, you're going to have your 70-year-old male patient. You're going to get dispatched to unconscious, unresponsive, or maybe CPR in progress. You're going to get there and do all your basic stuff. So you get there, you look, listen, feel, right? So we go unconscious, so we go for a carotid pulse. They've got no pulse, they're not breathing. Okay, so we're going to start CPR. You're going to tell one person to start bagging, and then you're going to have the other person hook up your AED, and away you go. So what the machine is looking for when we do our 12 leads, so let me get rid of the heart here. What the machine is looking for on the pattern is this. So just like, again, like scribbly nonsense, right? And going back to what we talked about last week with AFib, if we remember what AFib looks like, okay, so there's your scribbly nonsense. And then we had QRS complexes that were irregularly spaced from each other, right? So the part I want you guys to focus on is the scribbly nonsense part. And let's say that these two are actually like, the two of these are actually the same size, so they're in scale to one another. So if you notice, like in your so your P wave, right? Your P wave is about yay big, and the QRS is much larger, and that's because the ventricles are bigger, and so there's more electricity there. So we get what we call amplitude. So there's more There's more amplitude, which is why the QRS is bigger than the P wave. And that's the same deal going on right here. In AFib, right? In AFib down here, you have squiggly nonsense, but it's smaller because there's less electrical activity because it's in the atria. And in VFib up here, it's bigger. It's the same kind of chaotic, disorganized, scribbly lines, but it's bigger. And a big, big difference that should be obvious right away is there's no QRS complexes in this, in VFib. Whereas in AFib, the top of the heart is quivering, right? It's in fibrillation, but the bottom of the heart's just fine. In VFib, it's actually the reverse. The bottom of the heart is not fine, and the bottom of the heart is bigger as far as your electrical signal, and so you're not going to see your P wave. You're not going to see your atria working. You're just going to see, you know, like we have drawn here, just random nonsense. So if you were to attach, so once the medics get there, right, if you take the AED away and you attach them to the life pack and put the pads on, then what you'd be looking for, and you can do this while you're doing CPR as an EMT, you can look over at the box, and if what you see when you stop CPR is all this scribbly, crazy nonsense, then that's VFib. And it's, I mean, you know, I'd say that's pretty easy to recognize. So let's get rid of AFib down here for a second, and you know, tell me if you can recognize the difference, right? So this would be asystole, right? Just a pretty much flat line. We'll talk about this. We might go over this in this video too, but this would be Vtach, which is just, giving a hint for the future video here, these are just QRS complexes. So I would say it's, at least, you know, maybe for me, but I think it should be the case for you too, that like this one, right, these all look different from each other. You know, it'd be hard to make the mistake of saying, well, Vtach looks like VFib. Well, no, Vtach looks like a bunch of triangles. Asystole is just a flat line. VFib is just all over the place, right? And it makes sense because electrically, what's happening in the heart, right? Like we said, we'll draw the heart here. There's just points all around here saying beep, 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 beep. And so it's fibrillating. While we're at it, let's just go over Vtach because we've got it written down here. So let me erase all this and then we'll talk about that because those are the two shockable rhythms. So, you know, if anyone ever asks you what are the two shockable rhythms, well, it's Vtach and VFib. So we'll write Vtach. So Vtach is in essence, and draw a heart again. So Vtach is just your ventricles beating really, really, really fast. And what you're going to get are this kind of like triangular pattern, right, that looks like this. And here's the crazy thing about Vtach compared to VFib. So in VFib, if you're in VFib, you're dead. In Vtach, you could be alive or dead. People can't sustain Vtach for a long time, so if you get there and you see them in this pattern, then something needs to be done about it because they're not going to live forever in Vtach. Like someone with AFib, right? We talked about last week. Someone could live with AFib 24/7, no problem. Vtach, not the case. So, but let's take the same person, right? You go there, you check they're unconscious, so you check their carotid pulse. They've got no pulse, they're not breathing, so you start CPR. You tell someone to bag, and you hook up your AED. And the AED is looking for this, and it sees Vtach. Well, Vtach is just going to be these wide QRS complexes. So if we draw, again, our normal heartbeat here, you know, I would argue it's pretty hard to like confuse those two, right? They don't look similar. But what you're seeing, what these are right here, it's just this. It's just the ventricle. But instead of it happening, you know, instead of having it regularly spaced, right, at a heart rate of like 80, we're getting it really, really fast, right? So let's say it's 280, 300, right? Super, super quick. So to finish up here, let's say, like, why do we shock VFib and Vtach, but we don't shock asystole or PEA? Because you see in the TV shows all the time, right? The line goes flat, and then they shock them, and the person sits up and starts talking again. And that's not real life, because the shock doesn't restart the heart. That's actually that's kind of just a Hollywood myth. What's happening is there's all these electrical points, right, saying beat in VFib. And so what we're doing with the electrical, because remember before we do this, the SA node's working. There's nothing wrong with the SA node. It's just getting outshouted by your ventricle because it's bigger, right? And there's more electricity there. So what we're doing when we shock VFib or Vtach is we are going and it is the loudest shock. It's the loudest voice of all of them. And it's saying beat. And it shuts everybody up. It makes the heart beat once. And then the idea is there's a period of quiet. And what we're waiting for is the SA node to pick back up and to say beat. And then all of a sudden we get our, so on the 12 lead, if we're in VFib and it looks like this, right? And then we shock, well, actually, let's do it in a different color. So we shock right here. Then what we're going to get is hopefully this period of quiet, right? And then the SA node picks up. The AV node hears it, holds it. And there we go. And we are back to like a normal heartbeat, right? Whereas if someone was in asystole, there's nothing. And then we shock here. Well, the SA node's not working, right? So there's nothing that's going to say beat. And so what do we get on the other end of the shock? Just another flat line, right? So the whole goal is to silence all the rest of the electrical activity, like we did right here, and let the SA node pick back up because it was getting outshouted. And there you go. You turn that patient around, and we have what's called, what you're going to hear in the field, ROSC, which just stands for return of spontaneous circulation, which is just a really fancy way of saying they have a heartbeat again, right? What's priority one after we get a heartbeat? We're going to get a blood pressure. And then the treatments for the patient are going to be based on what that blood pressure is. So we're going to do certain things to that patient all the way to the hospital based on what their blood pressure is. And there's a chance that they go back in to VFib or to Vtach or another like lethal rhythm. And if they're in Vtach or VFib, so let's say we'll come back up here. So, they have the nice PQRST going on, and then all of a sudden they're back into VFib. We shock. The SA node picks up again, and we're back. And that's CPR 101. So hopefully that was shed a little light on like why we do CPR and how we'd recognize it. The medic and the AED are looking for the same thing. It's just that if sometimes the machine isn't as sensitive or doesn't see what we see, and we can go ahead and make that call when the machine may say it could be a very fine VFib and the machine thinks it's asystole, whereas with our eyes we can see it and say, okay, we're going to shock it. So if you have any questions, go ahead and post down below. So thanks for watching.